Mobile Development Club, they focus on building applications, whether it's phone applications or web applications. They have done a lot of projects in the past, like they made a Tinder, but just for UTA radio app. So they do a lot of fun stuff over there. And if you want to learn about app development, current modern trending frameworks, Mobi is the type of organization that would be fit for you to do that.
The whole class, object-oriented software engineering, they wanted us to make a project that was actually going to be incorporated into like a real-world system to kind of teach you on how real-world software development is actually done. We created the WAQ system over a period of semester. I was able to be hired on to work at the Fab Lab to actually start incorporating it into the real system.
Game Developers Club is an organization where they focus on designing games. So if you want to learn how to use a game engine or a game maker type environment, that would be the best organization to go to learn about that. They have their own VR equipment, they have their own VR controllers, different technologies. Have been trendy in the past with gaming technology, so you can kind of develop games for that over there.
UTA's Computer Science and Engineering Department strives to offer a first-rate education, offering bachelor's, master's, and doctoral degrees in computer science, computer engineering, and software engineering.
ACM is a networking society at its core. You know, we're trying to get people involved in the school, involved in the opportunities that UTA is bringing us, specifically with like Handshake and companies trying to come in and talk to people about internships and full-time positions. ACM really is for professional development.
What tutoring options are available for computer science students? Well, ACM, which stands for Association for Computing Machinery, has a student chapter here at UTA, and they do private one-on-one tutoring by appointment, as well as they are starting up community study hours this semester. It'll be a group study room that will be set up that people can come in and study for whatever classes they may be in.
A course outside of your discipline allows you to see the world from a different perspective. You have courses like Robots, Digital Humanities, and Theater that has engineers, social work, educators, computer scientists. We all are learning from each other. It's a very important concept and perspective to have.
Senior design's been going on since the beginning of the program. The projects are supposed to be multidisciplinary, so it's supposed to contain a hardware component as well as a software component, and it helps to have experience in both. As we transition the program into a sponsored program, industry is providing more input into what the projects will be.
It's actually a touchscreen. We're charging it. So there's a battery you can...
Yeah, it's over there.
Try lining the three up the same. This one looks like it's set. I felt like I was doing something. We're good.
I said we're on the right track. Okay. So what do you see? You see him over there, and you see buttons here.
This image. This dongle doesn't. You guys get 2 clues. Okay. Yeah. Okay. Can't maybe put your legs like that. What am I going to watch?
Blue is left arm up, right arm, and then this.
Okay, wait. You just got 2 green lights.
2 green lights?
Yeah.
So you just got that? Yeah, he just tried that. It didn't work.
Try yours.
No, that was it.
Go.
I'm just talking about your results. I mean, I'm not that y'all think I'm worried about me.
Okay.
So right now there should be nothing for anyone at all.
Nothing?
Okay.
Okay.
All right. So in the presence of where we have.
So this is the active aerodynamic system for the Formula SAE car. So what it does is control air surfaces on the car to raise or lower depending on what the car is doing. So when you're driving around a racetrack, when you're going through corners, you want more grip, so you want to raise the wings. But when you're going down straightaways, when they're in the race position, that creates drag and that slows you down. So it moves them according to what the car is doing. So this system works off acceleration, so it analyzes the acceleration vectors on the car. And you can see a small circle here, so if you exceed this inner circle, it will raise the flaps and therefore generate more downforce. And then when you go back inside the circle, it'll lower them to reduce drag.
All right, so our project is with Elastos. We work on blockchain. We use blockchain to do peer-to-peer messaging without going to a centralized server. So, as you can see, messages send in pretty real time, even though it goes through the blockchain. This works with Elastos' blockchain. It uses these things called sidechain, which is a smaller blockchain on top of the blockchain. So the sidechains get computed a lot faster than doing it on the main chain. So that's really the benefit to this.
It's really analogous to multi-threading in a way, in that everything can be done concurrently.
Yeah, so we add friends through QR code scanning.
Kids, I'm still at it. Unless you deleted me, I'm still at it.
Sorry. Yeah, QR scanning. And we have our account info. I don't know what that's doing.
Yeah, the account info, you can have picture, name, phone, email, and an actual QR code that represents the address on the carrier network developed by Elastos that's representing the public-private key pair combination.
Yeah, and that's about it. It's a privacy-based chat application. Our project is called ELA Waves.
Thank you.
What's happening right now is the robot is taking a photo, and you can kind of see.
Louder?
It's taking a photo right now. Move that now. And those tags you see right here are telling it the XYZ location in space. And we're using those tag locations to tell the robot arm where to go. So basically what's doing is it's finding a valid block to pull. Our algorithm basically picks from the side blocks first, and then if there's no valid side blocks to pull, we'll start pulling center blocks. And after it takes that turn, we have a solenoid with a vacuum pump on it, and that's going to suck the block to the vacuum gripper and sits it on top. Let's try that again.
So part of the game is that it's supposed to be collaborative, so you're supposed to be playing with a human. The idea of our project is that we're trying to get students, younger students who aren't yet figured out what they want to do, interested in STEM by showing them what you can do with like STEM technical skills. And so what we're doing right now is like we're combining, like we had to use the math, the computer vision, some of the computer science concepts, and robotics, which deals with mechanical engineering as well. And so all this is kind of combined to this project. So because it's a collaborative project and it's supposed to be interactive, the robot and the human take turns. So the robot's taking its turn right now, and so when the game state goes to red, that indicates that the robot's making its moves. And then once the robot finishes making its move, it goes to green, which is for the human player to take their turn.
We did it. Okay, found the spot. Yeah, just thinking for a while there.
And now it's going to go green, so it's going to be the human player turn.
Right, so this is our automated chess board, and so you are able to play against the machine, and so you have the arm moving, and the black pieces are the AI, and then we are the users. So we have a display here. Right now we have it hooked up to the monitor, so you can't see it, but when you start the game, it asks you what piece you want to play, and so we're white, and after you start it, you can basically make the move. We have a camera inside that detects what move you made, and the AI is able to play against you. And we have different levels as well, so the higher you go, the harder it is.
So I'm Hong Jiang, the chair of the Department of Computer Science and Engineering. Wow, I was really impressed. What a magic and what a success. So you guys put on a real fantastic show and tell. It shows the ingenuity, creativity, and dedication behind the magic. And it obviously tells the sweat, the tears, and I'm sure many sleepless nights working on the project, right? So congratulations to everyone. However, none of this would be possible without the superb guidance and the supervision of two Chris's, right? So let's thank Dr. McMurrow and Dr. Connie. They deserve a lot of our gratitude, and to show them a token of our sincere gratitude, I give them 2 crystal balls, right? This is for Chris McMorrow. Thank you so much. This is for Chris Connie.
So I just want to say thank you to all of you for all the hard work. I can not mess this up here. Thank you for all the hard work you've put in over the last 2 semesters. Hey, we had the mayor show up. That's pretty cool, right? So I wish you all the best luck in your careers and your future endeavors and everything. If you need anything, feel free to reach out to me, LinkedIn, email, whatever. But good luck to all of you, and enjoy your summer break if you get one. Probably not, because you're probably out looking for jobs or starting jobs, but enjoy the weather at least. So.